Hi, my name is Madeline Cornelia, and I'm a product consultant here at Tableau.
And I'm William Lang, and I'm a software developer with Tableau.
And welcome to Dev Storytime, Wrangling Cloud Data, and potentially the final session of your TC.
So, did you know that 82% of enterprises have a multi-cloud strategy? More data is being stored in the cloud, and it's more important than ever that we get a hold of it. So in this talk, you'll hear about two unique experiences of wrangling cloud data and bringing it into Tableau. I'm going to start with my story first, and Madeline will tell hers during the second half of the session. So as I mentioned, I'm a software developer with Tableau, and I work on the Tableau Online team. Can anyone guess what country I'm from? I'm very much stereotypical Canadian. I play hockey. I coach hockey. I've refereed hockey in the past, and of course, I yell at the TV screen while I watch it. When I first started playing, my grandmother bought me NHL 98 for the computer. My first computer, by the way, was a Ambra Inspirati. It had 133 megahertz and 8 megabytes of RAM and ran Windows 95. And she bought it for me, and I am quoting her here because she thought it would help with my game. Well, not only did I play any chance I got, skate at any chance I got, but you could also play this game online. And groups of players would form clubs, and clubs would have websites. The club that I was on wanted a website, and I volunteered just without knowing what that entailed. And before you know it, I had developed the two most pivotal hobbies of my life. And that brings us to Icy Data. Icy Data is a hockey statistics website that I work on. I'm going to be talking about how I wrangled my data, how I put it on my website, and most importantly, how I use that data with Tableau. And shameless plug, you can find it at www.icydata.hockey. So here's one of the many summaries that the NHL provides. This is a game summary. And right away, when I looked at this, I saw, the team names, goal scorers, players that were on the ice, penalties, what arena they were in, the attendance, the start and end time. There was so much data on here. I got super excited. And I needed to get this data in Tableau, and I needed to get it into Tableau yesterday. So as developers, the first thing you do is find out if there's a library out there that someone else has already made that'll do the job for you. There was a library called NHL Scraper that took already compiled data sets and used it with R. Not exactly what I was looking for. Now, however, you can use a Python library called NHL Scrappy. I didn't make that, but it's out there if you guys are interested. I was actually quite happy there was nothing there because that allowed me to make my own. I'm a developer through and through. And the strategy I used was web scraping. Initially, you're not going to know if you want to do web scraping. You're going to decide to scrape your data once you've sadly realized there's nothing better like a JSON or XML feed. So, and the first thing you want to do, find your data source. That's what you're going after. Second, develop and find a strategy to scrape your source. And most importantly, do not cause the source to block you by repeatedly going after the data. Cache your data so you can do your testing. So let's go back to that summary. What did I do first? I needed to figure out how I could create my scraper in such a way that I could get any game I wanted from any year, any time. So I started with the URL of the summary. Humans are really good at finding patterns, and the first thing I noticed was the year, 2015, 2016. The game was from the 2015-2016 season. The other pattern is the file name. With a bit of detective work, we can see that GS stands for Game Summary. And we've got game 1058 up there, which is also in the file name. But what did that 02 mean? As it turns out, each season has a type. There's the preseason, which ended up being 1, the regular season being 2, and the playoffs being 3. And what was really great about this is September of this year in Toronto, Ontario, there was the World Cup of Hockey. And the NHL was hosting the summaries for the World Cup of Hockey as well. And all they did was add 3 more types, 6, 7, and 8. We had the World Cup preliminaries, the World Cup, and the World Cup finals. All I had to do was add those 3 more types, and off my scraper went. Literally 0 work. So now you need to decide how you're going to scrape the data. And like any good educated developer, you go and search Stack Overflow. chances are many people have had the same problem you're having, and it's already been solved. I ended up deciding on a technology called XPath. Has anyone used XPath? Anybody? Oh, right on. Cool. And for those of you who are in QA, Selenium, if you use Selenium, also makes use of XPath as well. And XPath stands for the XML path language. It's a query language that will allow you to single out a element in a XML document. It also works well with HTML. They're both markup languages. In my humble opinion, it would be much better to be called a markup query language, but there you are. If you're also thinking, well, why not just use an XML parser? You got your thinking cap on. XML, as you know, you can have a definition and you can get really structured data. You don't really have that with HTML. You could probably use an XML parser, but it would be really difficult. So I went with just a standard XPath scraper. So here's an example query to get the home team name out of the summary. This add-on that I'm using here is called XPath Helper for Chrome. There's also XPath Helper for Firefox. I preferred the Chrome one because it was all real time and I could just choose an element on there and it would give me the path. So I took all these queries for all the summaries and put them in my code base, and it took a really long time. And after I'd completed my scraper, I'm not kidding, the NHL released a new website. Luckily, the summaries remained mostly the same, but they released something new, a JSON feed. It wasn't a total loss. There are things in the JSON feed that the summaries don't have and vice versa, so now I'm making them complement each other. So here's a first look at what my scrape data looked like. Super rough around the edges, but I got the start time, I got the teams, I got the Montreal Canadiens there and their logo and their roster and that type of thing. And now I needed to get this data into some form of database. I had a lot of requirements. You might too, create a checklist. I wanted to display this data on a website. I wanted to put it in a relational database, and I wanted to use it with Tableau. So now I'm going to talk about features in 10.0 and beyond that help me get this data into Tableau. And for the longest time, I wanted to share real-time vizzes on games that were underway. And you could do that on a website easily enough, and Tableau Online has live data connections. And so using the REST API, I downloaded an updated viz from Tableau Online. It would refresh the data source for me. I got the updated viz. Then I tried to upload that viz to Tableau Public. Fortunately, Tableau Public doesn't have a REST API, so that didn't work at all. And if before 10.0, if you were somehow to relate the story to MontyPython, you might say that auto-updating vizzes in public was like the Holy Grail. So enter the Google Sheets connector. And there are many different ways to get your data into Google Sheets. I'm going to start with the easiest and work my way to the most difficult. And depending on how many rows you're trying to push into Google Sheets, you're going to have to use a more difficult approach. So the first methods are these import functions. So import data will import a CSV file. Import HTML will import a table. And you can actually specify which table on a page you want to import. There's also import feed, import range, and import XML. Now, all of these, here's a tip to keep your data fresh. You can use this if statement, and what it'll do is every minute it will actually update the document with whatever data you tell it to import. So all of these methods have limitations. Import data doesn't allow you to exceed 3 megabytes, which not that big. HTML, you get a little bit more leeway, but as you know, HTML documents can get pretty big, and import HTML only allows 8 megabytes. So why is the REST API more difficult? The Google Sheets API has to support multiple collaborators. Imagine you've got 1,000 different collaborators working on the same spreadsheet, and you change one column or cell in the spreadsheet. You're not going to want to send the entire spreadsheet to all those collaborators. You just want to send that little bit. So this is how you might start, simply by creating a CSV file and uploading it to Google Sheets. You want to pay attention to MIME types. So I'm using text CSV to upload my CSV file, but also notice I'm using the Google Apps spreadsheet MIME type here. And this is important because if you don't, Google Sheets the API will not automatically convert your CSV file into a Sheets file. And that's important because you get free storage with Google Sheets. Though that might change, I don't think they expected people to try and upload their entire database like I am to Google Sheets. So great. We've uploaded a file to Google Sheets. You might be thinking, well, I can just create a script that does this automatically. And for some, that might be enough. However, these have the same file size limitations, 3 megabytes for an upload. So I hit that limit pretty quickly. So then I thought, well, let's create a CSV for every season and then combine all of those sheets together. And Google Sheets even has a method to do that. So I thought all my problems were solved. Not so much. Google Sheets has limitations on every individual spreadsheet as well. So 400,000 cell limit per sheet, 256 columns, 200 sheets per spreadsheet. It took me all of 42 minutes to hit that cell limit, simply by having a sheet that had roughly 10 columns with 66,000 rows. I thought my journey was done here. I thought I wouldn't be able to have large data sets for my auto-updating vizzes. And then Tableau 10.1 saved the day. So we have the Google Sheets wildcard unions. So as I mentioned before, I created a spreadsheet for every season. So as you can see here, I'm using the wildcard on NHL games. So it loaded all of the games for every season that I had put in Google Sheets. In my final iteration, I've implemented all of the strategies. I still have to meet initial file size requirements. I'm separating the spreadsheets, as well as any subsequent updates I make to those spreadsheets have to meet those file size requirements. So I started to have to page the data that I was putting into Google Sheets. And as of right now, I haven't had to separate anymore, but again, the wildcard would allow me to do that. So I'm not going to spend too much on the fine details of the code, and you guys don't have to memorize anything, because you can get all of this in the developer Dropbox. So there's two utilities. One is Python, one is Node, and you can install the TC16 app that we've made for both. So there are three parts to this. You want to keep track of what row you're on, and you want to update the properties of the sheet as you add data to the object. That's that grid properties object. And that actually tells the REST API how many columns we're pushing, how many rows we're pushing, how many columns are in each of those rows. The second part is building the row data. So obviously, we're going to create a row data object for every row. But you also have to create a cell data object for every column in the row. And on top of that, you also need to create an extended value object for each value in the column. And then you actually need to set the rows on the update cells request object. And finally, we're going to make the request. So you'll see I'm creating a batch update sheet request there. One is to update the sheet properties. We're telling the Google REST API how many rows the sheet is going to be. Because if you don't, the REST API actually throws an error. It won't let you update it past the specified number of rows that you've asked it to allocate. And then, of course, the second request to actually update the cells with the data. So I've got my data wrangled now. Before I go into some of the discoveries I made looking at the data, I want to rehash a couple points. Find data that you care about. It makes it so much easier to work with. Develop a strategy to scrape this data. And ensure that you don't jeopardize your ability to get the data by making the source upset with you. And store the data in such a way that you can analyze it. So now I'm going to go into demo. So I've got a Tableau public profile. I'm going to duplicate this. Okay, so here's some of the vizzes that I've created. I've got several of them. That penalties viz there earned me front page status on the hockey subreddit, one of my most proudest achievements. But lately, the big reason why I wanted the Google Sheets wildcard unions was the shots viz. So I had over 400,000 shots that I wanted to get into Google Sheets. And you can see I've got my number of shots on the left. And that'll actually update, I think. There we go. Yeah, it updated. So every 24 hours, I've got a script that updates my data in Google Sheets, and then the Google Sheets connector in Tableau Public will actually update that and update my viz. And if I were to add another season, because of that wildcard, the Google Sheets connector will grab it, throw it in there. So I want to show you some of the discoveries I made looking at shot data. So I've got a viz here on shot locations and frequency. So my two discoveries here are a shot spaceship, and I've got a heart of the net as well. So the red indicates, I use a temperature gauge here. The red indicates more shots are from that area. Okay, and one of the main things I want to look at is clustering, another 10 feature. I didn't even know I wanted clustering until I threw it in here and looked at some of these NHL shots. So now I'm going to look at a viz here for ranked goal clustering. And this viz is really cool because it allows you to see outliers really easily. So those purple circles are clustered as high chance areas to score. It doesn't make much sense. It's behind the net. Well, as it turns out, when you take a shot from there, you generally miss the net. And so it's not called a shot on goal at all. And so there's only one shot from here that actually went in the net, because most times when people shoot from there, they miss the net. It's not even called a shot. So that's why that area there is 100% and considered a high scoring chance. So I can actually remove some of these outliers by just changing my indicator. And there's my shot spaceship that I was telling you about, that tail off. And then you've got the heart of the net. I wanted to also check out what kind of, how successful teams were at scoring. You'd think more shots a team takes, more likely they're to score. Actually didn't turn out to be the case. So here's a viz showing the number of shots in red, okay, and then their shot percentage in orange. So that's the number of goals divided by the number of shots. And you got Tampa Bay up there and Dallas, two offensive teams, really good at scoring. And then you've got the Florida Panthers and the Sabres down at the bottom. But what I wanted to see is the high rate of scoring areas are right in front of the net, that heart of the net area. So I thought, well, let's just limit the shots to that heart of the net area and see how this changes. And what I found was the two New York teams, they have the most shots in that area, but some of the worst scoring percentages. I'm not entirely sure why yet. I'm still looking into some of the data for that. And then you've got, on the complete opposite end of the spectrum, the Boston Bruins, who have very few shots in that area, but the best scoring percentage. I'm a Leaf fan. I hate the Bruins. I've got one more viz I want to show you, and this is part of my future aspirations for this project. I want to calculate and predict when a team is going to score. And I'm going to do this using a very wishy-washy term called momentum. And what's great about this is that it's affected by everything. The number of people in the game, the players on the ice, home versus away, whether the team is on a winning streak or a losing streak. And what's great about this is it's probably an unattainable goal, but one I'm going to enjoy chasing anyway. The whole point of this story is to tell you what kind of passion I felt getting any NHL data and sharing it with the world. And I'd love nothing more for you all to feel that same passion as well. So now I'm going to hand it off to Madeline, and she's going to share her story. If you have any questions, hold it to the end. We'll have lots of time to go over those. Thank you.
All right. So let's get it all set up here. All right. As I said at the beginning, my name is Madeline, and I'm a product consultant here at Tableau. And I want to kick things off by telling you two things about myself. So the first thing is I went to a Montessori school from kindergarten all the way up through 6th grade. Anybody know what that means? Do we have any Montessori grads? Nice, cool. So essentially what that is they have a teaching style that uses a lot of visual and sort of material products. So remembering back to this time in our lives where we were all probably learning cross multiplication and lots of fun long division. At Montessori schools, I learned this stuff using different colored pegs on a pegboard, and I actually learned long division using this huge array of test tubes with different colored beads in them. And I would rearrange all these materials to solve math problems. Now, if you asked me to do a long division problem today using test tubes and different colored beads, I would probably leave the room. However, I can easily tell you that the green beads stand for the ones place, the blue for the tens, and the red for the hundreds. So after all these years, although the method has left me, I can still identify the visual cues that conveyed this information. Skip forward about 15 years, and here I am working at Tableau. And I'm using colors and shapes to analyze information and learn about the world around me. So for better or worse, I'm doing about the same thing I did in kindergarten all those years ago. Now, the second thing you need to know about me is I love music. And I have a song or a playlist for every occasion. I've got my party music and my let's get some work done music. I'm a Jersey girl, so we have to have the boss up there. I also have my running late to a meeting music. I hit that one quite a lot. And finally, my gearing up for a big presentation at TC music. Got to have AC/DC in there. So being the data nerd that I and most of us are, I eventually started wondering if there were patterns in the types of songs I listened to. Did my tastes vary by season or by time of day? And what could these patterns tell me about myself? And most importantly, how could I get my hands on the data that would answer these questions? Enter Spotify. This is the application I use to listen to the majority of my music on. It was data that I cared about, but I had to determine if I could get it and whether it would actually help answer the questions that I had about my own listening habits. So I did what any good and lazy coder would do. I found a Python module to do the heavy lifting for me. And I threw together this script up here that would fetch all of my song data from Spotify. It's pretty easy. I actually got the data and I was able to start playing around with it. So as a proof of concept, it worked. I got the data and it was starting to tell me things. But the process wasn't ideal, and there were two major problems that I had with it. The first was, what if other people wanted to use this? I had a hunch there were some Spotify users out there who also used Tableau and were probably having the same thought process as me. So I wanted to make sure that A, this was available to others. And secondly, what if people didn't want to use Python? The script I wrote, a little bit messy, and you would have to customize it to use it yourself, and I didn't want that limitation. I wanted other people to be able to use it, and I decided that it shouldn't require coding. So we've got API and we've got Tableau, and anyone can guess where this is going. I decided to build a web data connector. So who here has used a web data connector in Tableau? Has anyone built a web data connector? Nice. All right. So what is it? A little bit of background. It's an HTML or JavaScript-based web application. It retrieves the data from another site, another website or sites, either via scraping or via an API, and then parses that data into a Tableau readable format. Now, why use it? You get to create the connector. Tableau doesn't need to natively connect to the source. You can choose what the data is and how you want to format it. So it's extremely flexible. Now, I knew it would be a challenge, but I figured that this would allow both myself and other people to access their Spotify data. Needless to say, I didn't really realize what a challenge it would be when I started. And it's worth mentioning here that while I do have a background in coding, I'm not a software developer like Will. So I make some cool dashboards, but I suggest you don't look too closely at my code, although it is all in Dropbox. And I commented some of it. All right, so what did I need to do to build this web data connector? Three main parts. First, I needed to authenticate individual users. So anytime you log into something, you log into Spotify, any website, that data, that personal data is sitting behind some form of authentication. For Spotify, that uses OAuth 2.0. Anyone familiar with OAuth workflows in this room? Okay, you can probably explain it to be better than I can, but we're going to give it a shot. I had no experience when I started out with this, so it was a lot of trial and error getting through that process. Second, you need to retrieve the data. For me, that meant getting a list of all of my playlists, then looping through that list and getting information about all of the songs on those playlists. And this was all going to be done via calls to the Spotify API. And then the third part is structuring the data into a Tableau format. So you have to create the table schemas, you insert the data, and then you register and initialize your connector. And this is all done via the functions in the Web Data Connector API that's maintained by Tableau. Sounds pretty doable, right? Of course, if it was that straightforward, it wouldn't make for a very good story. And I learned 3 main lessons going through these parts here. First is be aware of the situation you're in. Second is thank goodness for promises, which we'll get to. And the third is know what you want. And these are good lessons for building a web data connector and for life in general. And so with that, I decided to jump right in. All right, so the first step was authentication. And this OAuth 2 is essentially used to authenticate users without exposing their credentials. So you don't have to hard code any passwords or anything into your information. And this would let other people log in and see their data. As I said, I didn't know anything going into this. Now, however, I think I understand it a little bit better. Users sign in, which grants your app permission to request their secure information. This permission is then conveyed with an access token, which is used to validate all future requests. I'll explain in this very simple diagram up here. And this is the actual code that I wrote to handle the OAuth process. Clicking a button inside the Web Data Connector allows the user to log in. And once they do so, Spotify appends the access token onto the end of the URL itself. My code is then responsible for pulling that access token off the end of the URL and using it to authorize all future requests, so all of the different requests I was making to the Spotify API. Now, I had a little bit of help getting there. Tableau has a Web Data Connector simulator, which is a really great tool. If you've built a Web Data Connector, you might be familiar with it. Essentially, it allows you to run your Web Data Connector sequentially, one step at a time. So the first phase of my connector starts when the web page opens and the users start interacting with it. So I can run that first phase right here. Now, with some trial and error, I got this stage to work successfully in the simulator. So I could pull down the access token from the URL and start retrieving personal data. As long as this box had information in it, I was happy and the step was working. So I decided to test it in Tableau itself. And show you what happened. We had an error. It just so happens that the window that's popping up here is in fact a browser window, which makes sense. That means that it actually can have limitations like any other web browser. This internal browser that Tableau uses runs on WebKit. And Chrome, the browser I was using to test my connector, ran on a slightly different web engine. And so the upshot of all of this was I spent about 4 hours combing through these 10 or so lines of code before I realized that the includes function was not supported in the browser. So I just had to change that one. So caution there, and learn from my mistakes. Be aware of the situation you're in. If you're coming from a coding background, you'll know that knowing what you're working with is really going to improve the process. All right, so step 2 was retrieving my data. Now there are 2 main approaches to retrieving data, and Will walked us through his web scraping experience, and I ended up using an API. Built and maintained by Spotify, way for me to access all of the data that they had. Now, each of these approaches come with their own challenges. When you're dealing with scraping, you have to figure out how the data is structured. When you're dealing with APIs, you have to figure out how to structure your requests that you send into that API. So I used Ajax for all of my requests. This is what a typical request would look like. So here I'm asking for information about me. This is going to return my user ID and so on and so forth, information about me as a user. And I'm validating it, authorizing it with that access token. And then if it's successful, it kicks off this callback function. So that's going to return the data to me. So with Ajax, all of these requests get sent without waiting for the user to do any input. So it allows them to sort of run in the back while the users interact with the website. Once the site receives a response, like I said, it kicks off this callback function, and then you can analyze the data that you're getting back from that response. Now, writing all of these got me into something that I later discovered was called a callback pyramid. So essentially, I had my first function here, which went in and got my user information, my user ID. I then made a successful in the function, the callback function from that. I had another call that went in and got all of my playlists. I then had to have another call that went on inside of that one to get all of the songs off of all of the playlists. This all came to a breaking point when I had to write the final calls to retrieve all of the information about the songs on every single one of my playlists. Now, why was this the problem? So these final calls had to happen inside of Tableau's Web Data Connector function, which assembles the data into tables. So this function right here. Running the calls asynchronously meant that this function wouldn't catch the song data before it was passed into Tableau. I couldn't control when these functions ran, so I kept ending up with empty rows in my tables. I needed a way to run all of the calls at once, wait until they had all finished successfully, and then insert the resulting data into the tables that then get put into Tableau. So I employed my usual method. I trawled the internet and aggressively Googled in search of a method that would help me solve this problem. And I came across JavaScript promise objects. These allow you to package up multiple AJAX calls and send them all at the same time, wait until the data is returned, and then run the next part of your code. There are probably other ways to tackle this challenge, and some of them might be more elegant, but for me this worked, and I was able to retrieve my song data and insert that data into my tables. So I learned my second lesson. And on to stage 3. So this last stage was structuring the data for Tableau. And here what you do is you use these functions from the Tableau Web Data Connector API. You structure the schema for your data, so all of the different columns and the data types. You pull the data into those columns, and then you add it into the final table or tables. Now, looking at this code here, you may notice that it's actually similar to the extract API code, which I think is pretty interesting. I noticed that in working with both of them. Essentially, you are building a Tableau data extract when you go in and you pull this information in the Web Data Connector. So we can look in at this function right here, and we can see we're creating the schema. And then we're actually adding the data into the table there. So it's a pretty straightforward process, and once you get to this point, you're kind of almost home free. The issue that I kept running into was all of my different data types. So what I realized is I didn't actually know what I wanted from this data that I was retrieving. There's a ton of information about songs, song title, song popularity, the date. I had to format all of this, decide the right way to put this data together, and assemble it into the final table. So what I learned from this is it's very helpful to know what you want before you get to this stage. It's going to speed things up a lot. So figure out what actually, what your dimensions and measures you want to have access to are. And that is going to fix the problem of going back and forth and continually changing these few lines here. This is one of an initial version. There's a lot more in it now. So a pretty straightforward lesson that we learned from this one. Is know what you want beforehand. It's going to make the process a lot easier. All right. So we've learned 3 lessons. We've accomplished the 3 main things, and let's see how it looks. Something to keep in mind, I had a lot of friends and colleagues help test this out. I know about half of them could actually remember their Spotify passwords, and even fewer could remember their Facebook passwords. So something to keep in mind when you're user testing. Don't spam me. So here's the authentication stage. I'm actually logging in using Facebook, which you can use, but it's all through Spotify. And then that final click of the button is calling those Tableau functions that pull the data into the tables. And you can see I can drag it out. I've logged in, accessed all of my song data from Spotify, and we can see it right there. No errors. Very exciting. And so now I just want to give you guys a little view of what that data actually told me. So let's go ahead. And take a look. So these are all of my songs, every song I've ever added on Spotify. And I'm using a little bit of extra data here. So I've got information about the average energy for these songs, the danceability, whether or not they're acoustic. And I use clustering to analyze this. So I broke it down into 3 main clusters. I've got my upbeat songs up at the top here. And then we've got my sort of mid-range songs here, and then finally a little bit of the downer songs on the bottom over there. What I found interesting here is we've got a sort of parabolic shape here. So high energy songs, really high energy songs, are apparently a little bit more difficult to dance to. So something we learned there. I also decided to look at all the songs I've added over time, just to get a big picture view and start trying to answer that question about seasonality and different patterns that were emerging in my data. So there are a couple things we can easily see with this one. And I did some sleuthing. And I realized that summer after graduating, I was on the job hunt, and I did a lot of biking and listening to music. And the summer before my senior year, I think it was pretty busy back then, but I seemed to be in a pretty good mood. And I have no idea what was going on over here. I also decided to look at percent of total, so let's just see maybe some patterns that are going to jump out here. And although we get a little bit of up and down all over the place, not really too many patterns jumped out at me. I did a ton of analysis on this, and it seems that I can pull out some patterns, but it's not as regular as I thought it was. So I decided to look just overall, big picture here, broke it down by season. And something that we can spot here pretty easily is I listen to a ton of music in the summer. I listen to most upbeat music in the spring, which is actually, I think, makes sense. And winter is a bit of a downer time there. So some patterns were emerging, but I definitely knew that I needed more data. There's a lot more to be discovered here. So it's ongoing. I also decided to look at what are my favorite playlists. What do I keep adding to, keep coming back to over and over again? And here we can see I've got some random names here, so don't judge. And summer, I am pretty consistently adding to just in the summer. Christmas, I pretty consistently add to just around Christmas. Then I've got my start and my, apparently I didn't need pump-up songs as of, August 2014. I got over that. So some interesting stuff here. It's sort of a preliminary analysis. I've been working on this for months, and there's a ton of stuff I need to look into. And this is one thing that I really loved about bringing this data into Tableau. It made it a ton easier to just start answering those questions and asking more of them. Also found something I wasn't expecting. It turns out I have a tendency to add songs repeatedly to different playlists over and over again because I'll forget that I like them and then remember. So here I've added 1983 by Neon Trees in 3 different years to 3 different playlists multiple times. And I've done that with some other songs as well. So something interesting that I learned about my own music listening habits and or bad short-term and long-term memory. So that's just a quick view. There's a lot more where that came from. I'm still working on it. I'm still doing a lot of discovery. I was working on it on the plane ride here, and I'll probably take a look on the plane ride home. But I'm able to do this, all of this analysis, because of the Web Data Connector. So let's go back and close it out here. So the code, both of Will's and I's code is available on the Dropbox that we're going to share. There's a ton of community web data connectors as well. So people are constantly building these. There's ones for Facebook. There's ones for Twitter. There's a ton of different ones out there. And they're pretty awesome to work with, even if they're challenging to build. So what's next? I've been talking about the different things I've done so far, but next I want to improve it. There's a lot more I want to add to my Web Data Connector. I want to get more data. I want to make it more dynamic. I think it would be cool if people could select different types of information that they could pull about their own listening habits. Something to note, Spotify definitely stores how often you listen to songs. They won't give you that data. I'm sure they're using it for some crazy marketing schemes. So there's limits. There are definitely limits, and I didn't know about those until I started working on this. So I hit those pretty quickly, but there's still a lot of data up there that I can work with. Talking about Tableau 10 and up, Web Data Connector 2.1 is out now. I don't know if anyone's played around with it, but it's pretty awesome. We already could do multiple tables in the 2.0, but now you can actually create standard connections. So if you have multiple tables and you want to predefine the joins that you're going to use to combine those tables, that's something you can do with 2.1. So what I learned from this, a lot of different things, but essentially a good hypothesis is going to generate more questions. So there's a lot more to do here, but I've learned a ton from this process, and I hope that you guys enjoyed hearing about it. And now Will and I both shared stories about how we wrangled the data we cared about. So we picked data that had a big connection to us and we wanted to learn more about it. Each of our techniques answered our questions but also prompted a lot of new ones. And so now we're going to challenge you guys, either using the techniques we shared today or your own methods, to go out and find the data that you care about to tell a story. All right. Kept it under time. So if anyone does have any questions, feel free. We can do some Q&A. Yeah?
Question about using Google Sheets with Tableau server.
Yep.
Have you done it with dual factor authentication? Is there an issue with being able to, because I know I've done it using just a regular account, but on our business side we require dual factor authentication. I haven't tried that out yet. I'm suspecting it's not going to work.
Interesting. Yeah. So if you authenticated, you'd probably get like a text message or something like that, or an email saying, "Here's a code."
Yeah.
Yeah, that's interesting. I haven't had to deal with that. One thing you might try is, so I've got a service account that then shares the specific Google Sheets with another account.
Okay.
So you'd have a service account that you specifically.
Share with would not have dual factor authentication.
That's right.
Okay.
Yeah.
That's a good idea.
Oh, and before everybody starts leaving, I right-clicked.
Yeah.
Please complete the session survey to let us know how we did. We'd love to come back next year and make an even greater talk. Any more questions?
You mentioned Dropbox.
Yep.
Or something. So how would we get the information that you guys talked about?
So I think they'll be sharing on the Tableau website, I believe.
Yep.
They're putting all of the shared content on that, the conference website. Yeah, should get it to you. Tableau Conference Live, I think it's called. It should give you all of it, yeah. So once it's all over, everything's going to be uploaded, yeah.
Okay, great.
All right. Thank you very much, everybody.
All right.